Hi everyone, this is 9.1 part 2, and as a quick refresher, in part 1 we talked about angles in degrees and radians, and that's a very important first step. Before you can really study trig, you have to be real comfortable with angles in both degrees and radians. For part 2, we're going to keep talking about angles, and I'm going to go through about 3 different little mini lessons on other important things about angles. Now the first one is called coterminal angles. And if you think about that word coterminal, co means shared or the same, and terminal, we talked in part 1 about how angles have a terminal side. So really, coterminal means two angles that end in the same place, same terminal side. Now in standard position, every angle starts in the same place. We all have the same initial side. So really what you're saying when you're talking about coterminal angles is any two angles that start and end in the same place. Now, if an angle starts and ends in the same place, you might think, well, it's the same angle, but it's all about how you get there. So basically, if you have an angle and you go one full rotation around the circle, you'll end up at the same place. That's what we mean by coterminal angles. So that means if you need to find coterminal angles, you can do that by either adding or subtracting, forwards or backwards, full rotations. And I said if it's radians, you're adding or subtracting 2 pi, that's one rotation. And if it's degrees, you're adding or subtracting 360. If you add, you're moving forwards, that's clockwise. And if you subtract, you're moving backwards, that's negative or counterclockwise. And then just one last little thing here. Every angle has an infinite number of coterminal angles because you can keep adding rotations or subtracting as many times as you want. So if I say find a coterminal angle, there's no one answer. There's an infinite number of answers. I'm basically asking you to find one of them. So here's our first example for today. I said our angle theta is 18 pi over 7. So it's a radian angle. And I said, what is a negative coterminal angle? So I didn't just say find any coterminal angle. I want you to find a negative one. So I say, well, let's start with the 18 pi over 7. And if it's radians, so I can find coterminals by either adding or subtracting 2 pi. Now, if I want to find a negative one, I should subtract. I can keep adding forever. It's never going to turn into a negative number. But if I subtract, that's how you can find a negative one. So I'm going to start by subtracting 2 pi. And then I say, okay, well, it's a subtraction problem with fractions. I need a common denominator. So let's put the 2 pi over 1. The common denominator would be the 7 for my original angle. So I'm going to multiply top and bottom by 7. And I get 18 pi over 7 minus, that would be 14 pi over 7. And that would equal 4 pi over 7. So I found a coterminal angle by subtracting 2 pi, but that's not negative, it's still positive. So it's not the answer I asked you for. So what I want to do is subtract 2 pi again. Basically keep subtracting 2 pi until the answer comes out negative. That's what I'm asking you to do. So let's do it again. Let's take the 4 pi over 7 and let's subtract 2 pi again. Now instead of repeating my work and finding a common denominator, I'm just going to keep subtracting 14 pi over 7 until I get a negative number. And I got one. 14 minus 4 is negative 10. So I get negative 10 pi over 7. And that's the answer I'm going to give. It's not the only answer to the question. That's basically the first negative one. That's the one that you would probably find first. But if I subtract 2 pi again, that's going to be a negative coterminal angle. And if I subtract 2 pi again and again and again. So there are actually an infinite number of possible right answers to this question, but that's the first one, and I think the most obvious one. So for my answer, I'm going to say a negative coterminal angle of theta would be negative 10 pi over 7. And let me give you a quick visual of what's happening here. It turns out, let's see, 4 pi, if I drew 4 pi over 7, it would be about here. And I did that kind of mentally, like from part 1. I said if the top half of that circle or the top half of that graph is 1 pi, If I wanted to do 4/7, that's about 4/7 of the way around. So the first one, 18 pi over 7, what you are actually doing is you're starting at 0, you're going one full rotation around the circle, and then ending at that place. The red one is actually 4 pi over 7, just the angle that you see, getting there as quickly as possible. And the green one is if you go backwards. So if I start at 0 and I measure this way, all three of those angles end up in the same place, but technically they're not the same angle. They are different. But they are called coterminal angles. And with a lot of the stuff you do in trig, they do end up essentially being the same thing. All right, our second little mini topic for today is conversions. So in part 1, we talked about degrees and radians, and let's say you wanted to convert one to the other. You have something in radians, you want it in degrees, or you have something in degrees, you want it in radians. Our key conversion factors, if you think about two things we know are equal, one full rotation in radians is 2 pi, and one full rotation in degrees is 360. So those two things are equal. 2 pi radians equals 360 degrees. Now we can simplify that a little. If you divide both of those by 2, basically you get pi equals 180. And that's going to be our conversion factor. That's the best way to convert, is to think pi radians is 180 degrees. And if you turn that into a fraction, either pi over 80 or 180 over pi, that's how you can convert. So if I want to convert radians into degrees, I multiply by 180 over pi. And if I want to convert degrees into radians, I multiply by pi over 180. Now, if you're trying to remember which one to do, you can use what's called unit analysis. And unit analysis is when you use the units in the question to realize what you're actually doing. So for number 1, I am starting with radians here. If I multiply by degrees on top and radians on the bottom, then see what happens is I cancel out the radians and I leave my answer in degrees. Now if you look at the second one, you are starting with degrees and you do the opposite. You cancel out degrees and you leave radians in your answer. So what you're doing is whatever you're starting with, when you're doing a conversion, whatever unit you're starting with, that goes on the bottom of your fraction to cancel out that unit. And whatever unit you want to end up with goes on the top because that's what you want your answer to end up in. And that, again, that's called unit analysis. So here's an example. Let's say we want to convert 7 pi over 12, 7 pi over 12 radians to degrees. So let's do that. I'm going to start with my 7 pi over 12 radians, and I'm going to multiply it by a fraction. So I say, well, it's either pi over 180 or 180 over pi. And you say, well, my answer is in radians, or my question is in radians, and I want it to be in degrees. That means I'm going to put the pi radians on the bottom to cancel that out, and the 180 degrees on top. Now, let's say we want to do this without a calculator. We get some big numbers here, but you can simplify first. Like number 1, the very first thing I would do is I'd say, well, I have pi on top, pi on bottom. Let's cancel that out. And then I have a 180 on top and a 12 on bottom. I could easily divide both of those by 12. 12 does go into that. It goes into it 15 times. So I can cancel this and turn this into a 15. And see, now after simplifying, I don't even really need a calculator. My answer is just 7 times 15, and that comes out to 105 degrees. So the answer, 7 pi over 12 radians, ends up being 105 degrees. Now I do want to emphasize, I mentioned this in part 1, you don't want to do this all the time. It would be a very bad habit for you to say, I don't like radians, so every time I see a 7 pi over 6 or a 2 pi over 3, I'm just going to multiply and I'm going to turn it into degrees and I'm going to do degrees for every question. That takes a lot of time. It adds a step to the question where you might make a mistake. And in the long run, it's going to be bad for you because you're going to start seeing more and more and more questions in radians, and you just got to get used to them. Okay, our third and final little mini topic for today is complements and supplements. And I'm guessing you probably remember these. If anything, you might be like, which one is which? So complements are two angles that add up to 90. That's probably the first way you learned it back in Math 4. Now in radians, 90 degrees is the same as pi over 2 radians. So if you're talking radians, instead of adding up to 90, they add up to pi over 2. But again, that's the same thing. This only includes positive angles. So like you can't say 100 degrees and negative 10 degrees are complements because 100 plus negative 10 is 90. 100-degree angle doesn't have a complement. It's too big. Anything over 90 does not have a complement. And there's my example again. 100 degrees and negative 10 are not complements because you can't use negatives. 100 doesn't even have a complement. And then supplements are the exact same thing in every way, except they are two angles that add up to 180 instead of 90. And that would be pi in radians instead of pi over 2. So basically, if I give you a question where I ask you guys to find a complement or a supplement, it's always done by subtraction. If it's degrees, you just got to figure out which one. If I ask for a complement, subtract from 90. If I ask for a supplement, subtract from 180. If it's radians, and I ask for a complement, you subtract from pi over 2. And if I ask for a supplement, you subtract from pi. So this will be our final example for today. We're going to find both the complement and the supplement of 9 pi over 13. And I said if each one exists. So let's start with the supplement. Supplement is subtracting from pi for a radian question. It's subtracting from 180 in degrees. It would be subtracting from pi. So I'm going to do pi minus 9 pi over 13. Now, just like our coterminal angle question, I need a common denominator. So I'm going to take that pi, put it over 1. I'm going to multiply by 13, and I get 13 pi over 13. And 13 pi over 13 minus 9 pi over 13 would be 4 pi over 13. And that's your answer. And that's why I said on the last slide, it's simple subtraction. It's one subtraction question, and whatever you get for the answer is the answer. Now let's try the complement. Complement is the same thing, but I'm going to do pi over 2. I'm going to subtract from pi over 2. So I'm going to do pi over 2 minus 9 pi over 13. Now this time my common denominator would be 26, so I'm going to have to multiply both of them. I'm going to have to multiply the first one by 13 over 13 and the second one by 2 over 2. So that would be 13 pi over 2 minus 18 pi over 2. And see, that's a negative number. That would actually be negative 5 over 2. But negative 5 pi over 2. Negative 5 pi over 2 is not the answer. Don't box that up. What you want to do instead is say, you can't use negatives. Throw that one out and say this one has no complement. So each question is subtraction. Just remember, if you ever get a negative for your answer, that means that that thing does not exist. There isn't one. There isn't a complement in this case.